Hello everyone, welcome to the next lecture on the numerical linear algebra. Today I will explain you the concept and the derivation of the two-point Gauss quadrature formula. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel. Now what we have discussed in this lecture, we will derive the expression of the two-point Gauss quadrature formula. Remember what we have discussed so far? The Gauss quadrature formula is the extension of the Newton's code formula. Remember, the Newton's code formula is applicable only whenever Newton code formula is applicable only when the value of the xi's are known to us. The value of the xi is this one. Fine. While in the case of the Gauss quadrature formula, the value of the xi's are unknown to us. Fine. And for more detail about the Gauss quadrature formula, you can watch about my numerical linear algebra playlist and look at these lectures in this list. Remember that in the Gauss quadrature formula, the value of the lambda is called as a weight and the value of the xi called as the positions, or we call as a nodes. Both are my unknowns. The two-point Gauss quadrature formula is basically the extensions of the trapezoidal rule approximations. We all know how we can integrate the function fx into dx by using the trapezoidal rule, as we have discussed in our lecture composite trapezoidal rule as well as the error analysis. Now, because the two-point Gauss quadrature is the extension of the trapezoidal rule, so we have to follow the same kind of the assumptions as we did in the composite trapezoidal rule. Remember that once we have discussed the trapezoidal rule, once we have integrated the value of the a to b, we have used the formula is h over 2 f of a plus f of b. Fine. And you can see in this case the value of the a and b are always known to us, and the value of the a and b are called as the endpoints, nodes, quadrature points. Fine. And if you are using the composite trapezoidal rule, then instead of the formulas is f of a, fine, plus twice of the next element, fine, and so on, plus last element, fine. And the same formula I have explained you in the composite trapezoidal rule. Now, in this Gauss quadrature formula, or called as the two-point Gauss quadrature formula, our target is, if you have the points say 1 or -1, fine, we have to choose the 2 point in between them, say x1 and x2, fine. Because if you look about this formula of the trapezoidal rule, the value of the a and b both are known to us because these are the limits of the endpoints, fine. But in the Gauss quadrature formula, or the two-point Gauss quadrature formula, we have to choose the value of the x1 and x2 in between the a and b, and these are my unknown to you, fine. These are my unknown to you, and the question arises is how we can choose these 2 points, how we can find these quadrature points, and why we need these points are there. The answer of question arises is why we need these points, because we want to increase the accuracy of the trapezoidal rule. Now let's see how we can find, the question arises is how we can find the value of the x1 and x2. We have defined the Gauss quadrature formula because we are talking about the 2-point, I can choose n is equal to 2. So once I can choose n is 2, then my formula becomes lambda 1 f of x1 plus lambda 2 f of x2. फाइन, एक आपको पहले बता दे रहा हूं, जो भी आपके पास, बिकॉज our target is to find the value of the lambda 1, lambda 2, x1, x2. एक पहले बता दे रहा हूं आपको, जो भी आपका आंसर आए, ओके, the sum of the lambda I must be 2 and sum of the xi must be 0. चाहे वो 2 पॉइंट क्वाड्रेचर है, चाहे 3 पॉइंट है, चाहे 4 पॉइंट है, कुछ भी है, आपका आंसर यही होना चाहिए हमेशा. सम ऑफ द लैम्डाइज आर ऑलवेज 2, सम ऑफ द एक्साइज आर ऑलवेज 0. इसका मतलब जो भी आपके पास आंसर आएगा, वी विल सी वेदर दीज टू कंडीशन विल बी सेटिस्फाइड और नॉट. आप इस तरह से अपना आंसर एग्जाम में चेक भी कर सकते हो आप भी. फाइन, चलिए. So our target is to find the values of the, so how many unknown are there? So our target is to find the 4 unknowns. Fine. So I can choose a polynomial fx. I can choose a polynomial fx with the 4 unknown coefficients. That means a0 plus a1x plus a2x square plus a3x cube. Now these are the 4 unknown coefficients, or I can simply choose an as the basis of the fx. What are the bases? What are the coefficient of the a0? 1. What are the coefficient of the a1? X. Coefficient of the a2? X square. Coefficient of the a3 is x cube. So I can choose fx in such a way the equation number 1 becomes exact for the polynomial f1 x square and x cube. So once we can choose an fx is equal to 1 in equation number 1, so your integrations on the left hand side becomes 1. It will be lambda 1 of 1 plus lambda 2 of 1. I can substitute in the second equations. Once we can choose an fx is x into dx, it is lambda 1. F of x1, it is x1, lambda 2, x2. Third equations, minus 1 to 1, x square into dx, it is lambda 1, x1 square, lambda 2, x2 square. And similarly for the last case, minus 1 to 1, x cube, dx, it is lambda 1, x1 cube, lambda 2, x2 cube. Fine. Now can you solve this integration? The answer of this will be twice. So 2 is equal to lambda 1 plus lambda 2. Fine. Can you find the integration of the x? It is x square by 2 from minus 1 to 1. It is half minus half, that is a 0. So 0 is equal to lambda 1 x1, lambda 2 x2. Similarly for next is a 2 by 3. And for the x cube is my 0. Now you have the 4 equations and the 4 unknowns. So our target is to find the values of these lambda I and xi. It's a very simple. You can see I can use the equation whose right hand side is my 0. Fine. So I can multiply this equation by x1 square and subtract from the 4. So I can use the equation number 4 minus x1 square of equation number 2. Fine. So what will happen? The first value will be same. The second value will be lambda 2 x2 x1 square minus lambda 2. Sorry, I can choose x4, equation number 4, lambda 2, fine, minus lambda 2 x1 square x2 is equal to 0. I can take an lambda 2 is common, x2 is common. The expression becomes x2 square minus x1 square. Fine. So what will happen? That becomes, this becomes either lambda 2 is 0 or x2 is 0 or x2 is plus minus x1. Fine. Now what will happen if lambda 2 is equal to 0? If lambda 2 is equal to 0, then from equation number 2 we will get lambda 1 into x1 is equal to 0. From the equation number 3 we will get lambda 1 x1 square is equal to 2 over 3. Fine. So what do you get? This implies if lambda 2 is equal to 0, then from equation number 1 we will get lambda 1 is equal to 1. Fine. And lambda 1 is equal to 2. Fine. And when lambda 1 is equal to 2, from the equation number 2 we will get x1 is equal to 0. And once x1 is 0, that is contradict the equation number 3. Fine. So that means lambda 2 is equal to 0 is not possible. Is it okay? Similarly, I can say x2. Can the value of the x2 is a 0? So if x2 is equal to 0, what will happen? If x2 is 0, from equation number 2, we will get lambda 1 x1 is equal to 0. Fine. From equation number 3, we will get lambda 1 x1 square is 2 over 3. So that implies, because lambda 1 x1 is 0, that implies 0 is equal to 2 by 3. 0 is equal to 2 by 3, which is not possible. Therefore, x2 is also not possible. Fine. Similarly, for this case, it's a plus minus. So I can choose, find x2 is equal to minus x1. x2 and x1 are not same. Why? Because your target is to choose the value of the x2 and x1, which are entirely different. Fine. But anyhow, if x1 and x2 both are same, what will happen? If both are same, then from the equation number 2, I can take an x1 is common. That means lambda 1 plus lambda 2 is equal to 0. Lambda 1 plus lambda 2 is my 2. So that implies x1 is equal to 0. Fine. Once x1 will be 0, what will happen? From the equation number 2, lambda 2 x2 is equal to 0. But lambda 2 can never be 0. That means x2 is my 0. That means both are 0. That is not possible. And because they are not satisfied equation number 3 as well. So the only choice which is left behind is x2 is equal to minus of x1. I can substitute this value in the equation number 2. This implies lambda 1 x1 minus lambda 2 x2 is equal to 0. So I can choose an, here is x1 is common, lambda 1 minus lambda 2 is 0, because x1 is my non-zero, which implies lambda 1 is equal to lambda 2. Fine. Once lambda 1 and lambda 2 is same, then by equation number 1, we will substitute. We will get lambda 1 is my 1 and lambda 2 is also 1. And once we know the lambda 1 and lambda 2, I can substitute in the equation number 3. What will happen? It is both are same. x2 is equal to x1. So that will be x1 square plus x1 square, which is equal to 2 over 3. That implies x1 is plus minus 1 over root 3. Fine. So once you can get x1 is plus minus root 3, x2 will be minus plus 1 over root 3. So hence, my lambda 1 plus lambda 1 and lambda 2 is my 1, x1 and x2 are. So you can substitute the value of the lambda 1, lambda 2, x1 and x2 in equation number, this given equations. So your Gauss quadrature 2-point formula becomes here. So I can substitute the value, lambda 1 is my 1, x1 is my minus 1 by root 3, and so fine. And this equation is known as Gauss-Legendre 2-point formula. देखिए मैंने, you can check your answer as well. Sum of the lambda I must be 2, sum of the xi's must be 0, and you can see that sum of the lambda's are my 2, sum of the xi's are my 0. Always remember students, whenever you want to apply the Gauss quadrature formula, your domain must be from -1 to +1. If the domain is not from -1 to +1, that is from A to B, then your target is to convert the domain is to from A to B to -1 to 1. And how you can use? You can use the substitution as x is equal to b minus a divided by 2. B is my upper limit, a is my lower limit. B plus a by 2. I will tell you the examples. Solve or compute the integral by using the Gauss-Legendre 2-point formula. Fine. So the limits must be from -1 to +1, and it is already there. Fine. By the Gauss-Legendre formula, a is my -1, b is +1. What is the Gauss-Legendre formula? Fine. What is the fx? Fx is my 1 over 1 plus x square. So I can substitute the value. It is 1 over 3 plus 1 over 1 over 3. That will be 4 over 3 plus 4 over 3. So that will be 6 over 3. Sorry, 8 over 4 over 3, 8 over 3. Fine. It's a, sorry. It's a 3 by 4. It's a 3 by 4. It's a 3 by 4. So it's a 6 by 4. That will be 1.5 is the right answer of the problem. Look at the second one. Again, your target is to solve the Gauss-Legendre 2-point formula. But you can see the domain is not minus 1 to plus 1. The lower limit is my minus of 2. Upper limit is my plus of 2. So your first target is you have to convert the limits a to b to minus 1 to plus 1. How you can change them? I can use the substitution. X is equal to b minus a divided by 2 of u and b plus a divided by 2. I can substitute the value. B is my 2, a is my minus of 2. So it's a 4 over 2 and this number is 0. That means x is equal to twice of u. I can substitute here. So I need a dx also. Dx will be twice of du. So therefore, your integration becomes limits are from minus 1 to plus 1. E raised to power minus x by 2. X is my 2u. So that will be u twice of du. This will be u. 2 will be outside. E raised to power. Fine. You can check also when x is equal to minus of 2, u will be minus 1. When x is equal to plus of 2, u will be plus 1. So now the limits are from minus 1 to plus 1. So now therefore you can apply the Gauss quadrature formula. Here the 2 is outside, so this will be the 2. Apply the Gauss quadrature formula on this box element. Fine. So what is my fx? So in this case, because now they are the u, so you have to apply the Gauss quadrature formula on this box. So it will be minus of u. दिमाग में रखिए ये u नहीं होगा. It is not the f of x. Fine, because the limits are not from minus 1 to plus 1. So I can substitute the value. So it will be e raised to power minus 1 by root 3 plus e raised to power plus 1 by root 3. Now you can solve this by the calculator or you can write as 1 over 1.732. Fine. So you will get the answer is 4.6853 is the right answer of the problem. I will explain you with the help of that 20 plus examples in our next lecture. Till then, you can share this video. You can watch this playlist numerical linear algebra for the various other lectures related to the complete course of the numerical linear algebra. Till then, you can share this video with your friends. You can like and comment on it. Thanks for the watching. Happy learning always.